Hello everybody, we're getting ready to do section 8, SAT Math Level 2 preparation. And this is exponential and logarithmic functions, part 1. You got 8 points on your notebook guide, have that out. 12 points on your classwork sheet, have that out as well. Name, date, period, in my classroom, due date for onliners and homework. Page 1 of chapter 8. Exponential functions are to form y equals a to the x, where a is greater than 0 and a does not equal 1. The inverse of x equals a to the y is obtained by interchanging x and y. Begin this statement with y, and it reads y is the power of a that makes x. So y is the power of a that makes x. Or y equals log base ax. In other words, log base a is an abbreviation for this phrase here. Y is the power of a that makes x. The power of a that makes the basic exponential properties. So for all positive real numbers x and y, in all real numbers a and b, x to the a times x to the b will equal x to the a plus b, because they have the common base here of x. This is the product of powers property of exponents. And then x to the a over x to the b equals x to the a minus b. This is the quotient power of exponents. And then here's the product power of exponents. Again, the power of a power be x to the a to the b power be x to the ab. Then x to the 0 will equal 1. X to the negative a is the inverse of 1 over x to the a. Inverse of x to the a. And then x to the a times y to the a will be xy times a. These are all exponent properties that you should have had by now. The basic logarithmic properties for all positive real numbers a, b, p, and q, in all real numbers x, and where a does not equal 1 and b does not equal 1, we have log base b, p times q will equal log base b, p plus log base b, q. Then log base b, p over q will equal log base b, p minus log base b, q. Then log base b, p to the x will equal x times this x goes out in front now of your log, x times log base b, p. And then log base b 1 will equal 0, because we're going b to the 0 power will equal 1. And then log base b will equal 1, so b to the first power will equal b. Then b to the log base b, p will equal p. This base will cancel with this log base b and your as an exponent. These will cancel, and then p will drop down, and it will equal p. Then log base bp will equal log base ap over log base ab. Will be a change of base formula here. Log base a p over log base b b. Here log base ab will be a change of base formula there. I don't really like the way they've done that, but this is your change of base formula here. And again, these are all reviews of that. So let's try one here. Simplify x to the n minus 1 times x to the 2n times x to the 2 minus n squared. So how will we simplify that? This is equal to x to the n minus 1 times x to the 2n up here times x to the 4 minus 2n. And it'd be the same thing as x to the n minus 1 plus 2n plus 4 minus 2n. We just add up all of these exponents here because they all have the same base, and when you add all these up you get x to the n plus 3. And then b here, simplify 3 to the n minus 2 times 9 to the 2 minus n over 3 squared minus n, 3 to the 2 minus n. So for that situation, in order to combine exponents using the properties above, the base of each factor must be the same. So 3 to the n minus 2 times 9 to the 2 minus n over 3 to the 2 minus n will be, we're going to make this base here 3. So to do that, 3 to the n minus 2 times 3 squared, which is 9, to the 2 minus n over 3 squared to the 3 to the 2 minus n. Now they all have the same base, so now we can use our exponent properties. So we can combine. Up here we have 3 to the n minus 2, then we add this up here, plus 4 minus 2n. And then here we're going to subtract 2 minus n, negative 2 minus n, using our quotient power of exponents. And when you add all these up together, you get 3 to the 0 power, which equals 1. So that would be how we arrive at that. C, if log 23 equals z, find a value of log 2300 in terms of z. So log 2300 will equal log of 23 times 100, which would be the same thing as log 23 plus log 100, which will equal z plus log 10 squared. And then when you take, this is log base 10 here, the two tens will go away, your log will go away, it will just be 2 then. The 2 will drop down, and you end up with equals z plus 2. D, if natural log 2 equals x and natural log 3 equals y, find the value of natural log 18 in terms of x and y. So natural log 18 will equal natural log 3 squared times 2 will equal natural log 2 plus 2 times natural log 3, and then this will equal x plus 2y when you end up with that. And then solve for x here. Log base b x plus 5 equals log base b x plus log base b 5. So for that one, you have log base bx plus log base b5 will equal log base b5x, because you multiply these two together now, because you're using your sum property of logarithms. Therefore, log x plus 5 will equal log 5x, which is true only when x plus 5 equals 5x, 5 equals 4x, and then x will equal 5 over 4. Would be an example of that. F, evaluate log base 27 square root of 54 minus log base 27 square root of 6. If you can enter base 27 into your calculator, enter the entire expression to get the answer 0.3, repeating 0.333, which equals 1/3. Otherwise, you can use the change of base formula to substitute log base 54 here, log base 54 over log 27. For log base 27 times square root 54 and log square root of 6 over log 27 for log base 27 square root of 6. If you know your logarithms well, you can use properties to see log base 27 square root of 54 minus log base 27 square root of 6 will equal log base 27 multiplied by the square root of 54 over 6, which will equal log base 27 3 in this situation, which will equal 1/3. So basically the question is what power of 27 will equal 3, and the cube root of 27 will equal 3. The graphs of all exponential functions, y equals b to the x, here's what they look like down here. Y equals b to the x here, and then this is when b is between 0 and 1. You have a decreasing function. Then when b is greater than 1, you have an increasing function. have roughly the same shape and pass through 0.01, which is right here. If b is greater than 1, the graph increases as x increases and approaches the x-axis as an asymptote. So your x-axis will be an asymptote for each one of these. This one, as it increases, it starts here and it increases like this. This starts way up here and it decreases and uses the x-axis as an asymptote. The amount of curvature becomes greater as the value of b is made greater. If 0 is less than b less than 1, the graph increases as x decreases and approaches the x-axis as an asymptote as x increases. So anyway, if it's between 0 and 1, you have this curve like this. The amount of curvature becomes greater as the value of b is made closer to 0. The graphs of all logarithmic functions, y equals log b to the x, have roughly the same shape and pass through 0.10. So this would be an example of this here, y equals log base b to the x. If b is greater than 1, it has this shape. If b is less than 1 and greater than 0, then it has this shape here. The amount of curvature becomes greater as the value of b is made greater. If b is between 0 and 1, the graph decreases as x increases and approaches the y-axis as an asymptote as x approaches 0. So like this situation here. And up here as well. The amount of curvature becomes greater as the value of b is made closer to 0. So as b gets closer to 0, the amount of curvature is greater for that. Okay, so two numbers serve as special bases of exponential functions. The number 10 is convenient as a base because integer powers of 10 determine place values. For instance, 10 squared equals 100, 2 zeros, and then 10 to the negative 3 equals 3 places over to the right of the decimal point, or 0.001. The inverse of 10 to the x is log base 10 to the x. By convention, the base is not written when it is 10, so the inverse of 10 to the x is simply written as log 10, even though there would be a base down here, log base 10, 10, but we just leave the 10 out, the base 10 out. The other special base is the number e, 2.718281828. This is a non-terminating, non-repeating decimal. The inverse of e to the x is log base e to the x, which is further abbreviated natural log x. The natural log of x. On the TI-84 graphing calculator, the command log will evaluate the logarithm with respect to any base by entering the value whose log is being sought, followed by the base. So log base e, natural log, can also be entered directly. Exponential growth is an important application of exponential functions. Exponential growth reflects a constant rate of change from one time period to the next. Okay, so for G, the population of a certain city grows at 7% per year, and the current population is 100,000. What will the population of that city be in 10 years? So each year the population will grow by a factor of 1.07. Therefore, after 10 years, the population will be 100,000 times 1.07 to the 10th power, which is about 196.715. H. A bond pays interest at a rate of 3% compounded annually. How long will it take an initial investment to double? Each year the investment grows by a factor of 1.03. Therefore, the growth factor after n years is 1.03 to the nth power. Since the investment doubles when its growth factor is 2, we need to solve the equation when 1.03 to the nth power equals 2. Take the log of both sides to get n log 1.03 equals log 2. It follows that n equals log 2 over log 1.03, which is about 23.45 years. And that is your lesson section 8 of SAT Math Level 2 Prep. Animated PowerPoint Math Video at AOL.com for questions or course materials. Thank you very much.